Now, as an application about the diffraction of light, we are going to take some exercises, about 5 exercises, less or more, etc. Let's start with the first one. Okay, it says, the first one says, A, determine for a small angle of diffraction. So you have small angle of diffraction. This means that theta is less than or equal 10 degree, which is equal 0.174 radian. Okay? The width L of the central bright fringe in terms of lambda A and D. فإذن I want to find L, width of the central bright fringe in terms of lambda A and D. What are these? Lambda is the wavelength of the laser beam, A is the width of the slit, and capital D is the distance between the screen and the plane of the slit. So I need a figure in order to solve such a problem. This is the figure you have here. This is the screen. I am going to call it, for example, screen E, where the diffraction pattern appears. And here, this is the slit. This is the slit. And don't forget, the slit is of the order of 1 millimeter. Yani it is just a point. And here, this is the laser beam of wavelength lambda. Okay? So, if I call this point I, the orthogonal projection of I is O, which is the center of the central bright fringe, which I am going to draw it a bit larger in order you see it. This is the central bright fringe. You have here the first dark, which half the width of the central bright. And here this is the second bright. Okay? Similarly, you have here first bright, and this is the second bright. What is L that I want to find? L is the length of this one. Okay, width, or the width or the length of the central bright fringe. I want to find it in terms of lambda A and D. How to find it? As you know, we can calculate the angular position of the dark fringes. We have the formula, theta equal K lambda over D. So in order to find the length of L, I am going to draw here a ray, the diffracted ray. This is the diffracted ray, and this is angle theta 1. And similarly, you have here theta 1 prime. Don't forget, theta 1 prime is negative, is equal to minus theta 1. Okay? If you look at this triangle, you notice that triangle OIO, I am going to call this point A. What about this triangle? It is right at O, and it is perpendicular bisector of AB. So if I take half of it, its length will be L over 2. Okay? So in a triangle IOA, which is right at O, I can write فإذا triangle IOA is right at O. So I can use the tangent. Don't forget that D is given here. It is the distance between the plane of the slit and the screen. Okay? يعني if this is D, then IO has length D. So I can use tangent theta 1, which is equal opposite over adjacent. Okay? What is OA? I can replace it by L over 2. يعني equal L over 2 over D, which is equal L over 2D. Now we said that we have a small angle of diffraction. Because we have a small angle of diffraction, also there is an approximation formula for the tangent. So I can write theta 1 is small. يعني this implies tangent theta 1 is approximately theta 1 in radian. يعني this implies theta 1 in radian is approximately equal L over 2D. So cross multiply, L is equal to D theta 1 in radian. Okay, this is L. But what is missing here? Theta 1 is missing. Type theta 1, I can find it from the angular position of dark fringes. Okay? So here, the angular position of dark fringes for a small angle theta is given by theta equal K lambda over A, where K belong to Z star. But what I want from this formula is the angular position of the first dark fringe. So I write K equal 1. فإذا first dark fringe, يعني this implies K equal 1, يعني this implies theta 1 equal lambda over A. Okay? Now I can substitute this in the above formula. If I call this equation 1, I can say here, substitute in equation 1. So I'm going to change the color so that you substitute in equation 1. This implies L equal 2D lambda over A. يعني I can write L equal 2D lambda over A. And this is the length of or the width of the central bright fringe in terms of D, lambda, and A. Let's look at the part B. This was a part A. Part B. Okay. I'm going. Part B, He says, determine also for a small angle of diffraction the width L1 of the first bright fringe in terms of lambda A and D. So he wants L1 in terms of lambda A and D. What is L1? Let's look at the figure here. This is L1, first bright fringe. This is L1, or this one is L1, okay? So to calculate L1, I am going to call this point C. You have here A, B, this is point C. So L1 that I want to calculate is equal to AC. Type. I have theta 1. I calculated it. It is lambda over A. Look here. The first bright fringe is bounded by first dark fringe and second dark fringe. So I need to draw here to show theta 2, which is the second dark fringe. This is the second angular position for the second dark fringe, theta 2. Right, let's look. What is AC equal to? AC is equal OC minus OA. So equal OC minus OA. And I have D. So also here I can find OC by tangent theta 2, okay? And I can find OA also by the same method. So tangent theta 2 is equal opposite over adjacent, يعني OC over D. Okay, يعني this implies OC equal D tangent theta 2. And since we have a small angle, I can write tangent theta 2 is approximately equal theta 2 radian. يعني this implies OC is approximately equal theta 2 radian. And theta 2 can be calculated from the previous formula, angular position for dark fringes. You substitute K2, okay? Second dark fringe, yani this implies K equal to, and you get theta 2 is equal to lambda over A. So you get OC is approximately equal D times 2 lambda over A, which is 2D lambda over A. Similarly for OA, it is the adjacent side to theta 1, so similarly I can write, it is no need to repeat all this. Similarly, OA is equal D tangent theta 1, which is approximately equal D theta 1. But theta 1 I calculated before, and it is equal lambda over A. Also you can substitute K equal 1 in that formula, the angular position of the dark fringes, and you get this. So now I can find L1, okay? L1, we said it is OC minus OA. So 2D lambda over A minus D lambda over A gives you D lambda over A. So L1 is D lambda over A. Okay. Part C says compare the widths of the two fringes. So in part C, just I want to compare. This is L1, and I have calculated L to be equal to d lambda over A. By comparison, I am going to replace d lambda over A by L1. We get L equal to L1. Okay. I have proved this during the course when I have proved that the angular width of the central bright fringe is double the widths of the lateral fringes. Okay? There I prove it by angular width. Now I prove it by the widths, by the linear widths. And we get here length of the central bright fringe is double the central, the width of the first bright. Also, if I calculate length L2 of the second bright, you will get d lambda over A, and so on. And this also proves the experimental result that the width of the central bright fringe is double the widths of the lateral fringes. Okay. This is the end of the first exercise. Let's look at the second one. The second one, also similar to the first one. What do we have? Two A, okay? By choosing an x-axis vertically upwards along the diffraction pattern of origin O coincides with the center of the central bright fringe. So, this is the diffraction pattern. I am going to choose an x-axis vertically upward of origin O. Okay? He says this is D. He says determine for a small angle of diffraction the positions of the dark fringes and the positions of the centers of the bright fringes. So he wants the positions of the dark fringes and the bright fringes. Type. How to determine the positions? He told me to choose this as an x-axis of origin O. So this now becomes an x-axis. And as you know, on an x-axis, I determine the position by its abscissa. Yani this means he wants the abscissa of this point, which is x1, the abscissa of the second dark fringe that I am going to call it x2, and so on. So I want x, but for what? For all dark fringes. All dark fringes. Okay, how to find x? This is x1 facing theta 1. So also I can use tangent theta 1 is equal opposite over adjacent, and because theta is small, I can write theta 1 x1 over d. And you know x1 you can find it, theta 1 you can find it from the formula of angular positions, which is equal lambda over A. Substitute it here, you can find what? x1. Similarly for the second one, this triangle here is right. This is point A. ID we call it C. Also it's right. Okay? So I can write tangent theta 2 x2 over d with theta 2 equal 2 lambda over a, and so on for the all dark fringes. But I am not going to do this. I can find directly the abscissa in general for any point, whether A, C, D, for any dark fringe. Any dark fringe has abscissa X, which is variable. This is X. It can be C, it can be A, etc. And in general, it has angle theta. So I am going to find the positions in general. As you see, this triangle is right. So I write tangent theta equal X over D. Okay? Since theta is small, يعني this implies tangent theta is approximately equal to theta in radian. يعني this implies theta radian is approximately equal X over D. This is theta for any dark fringe. So dark fringes, the angular positions of dark fringes is given by, for a small angle, is given by theta equal k lambda over a, where k belongs at the star, or k equal plus minus 1, plus minus 2, etc. So substitute here. If I call this equation 1, substitute in 1, يعني this implies X over D is equal k lambda over a, which gives you X equal k d lambda over a, where k is this number, these numbers. And this formula gives me the position, linear positions, or abscissas of all dark fringes. During the course, I have found angular positions for the dark fringes. So, notice here, if I take first dark fringe, يعني k equal plus minus 1, يعني this implies x1 plus minus d lambda over a. What does this mean? This means that this is x1, this is the abscissa of the first one, which is given by d lambda over a, and the symmetric one here minus d lambda over a. This is called x1 prime, this is x1, and so on. Second dark fringe, k equal plus minus 2. You get x2 plus minus 2d lambda over a, which means the second one here is away from O, 2d lambda over a, and there is symmetric one minus 2d lambda over a. This is called x2 prime, and this is x2. Notice x prime are equal and opposite to x, and so on. He also wants the positions of the dark fringes and the positions of the center of the bright fringes. So positions of the bright fringes. How to find them? As we said during the course, I determined the position of the bright fringes by their center, because they have dimension. So this is the position of the first bright, and also this is the position of the first bright. This is the second. This is the second. Okay. The central bright fringe is given by x equals 0 because it is at the center. Okay. فإذا central bright fringe, this implies x equals 0. But how to find this one? This is an x-axis. This is the midpoint of this segment. Okay? يعني also this is the midpoint of this segment. And in mathematics, how do you find the midpoint? فإذا first bright fringe, I am going to call it x1 bright. It is equal to x1 plus x2 over 2, which gives you d lambda over a plus 2d lambda over a over 2 gives you 3d lambda over 2a. Similarly, for the dark one, you put, for the symmetric bright fringe, similarly, you put here minus d lambda over a, you minus 2d lambda over a, you get the symmetric one minus 3d lambda over 2a. Similarly, the second bright fringe, bright fringe gives you x2b bright gives me x2 plus x3 over 2, and you can find x3 by substituting k equal 3 in the formula. kd lambda over a, you get x3, you substitute x2, which is 2d lambda over a, 2d lambda over a. I can put the plus or minus for both, plus minus 3d lambda over a over 2, and you get the plus minus 5d lambda over a. This is one for the second bright, which is here, and one is here, and you can deduce the others. Third bright fringe, x3 bright. Okay, notice here you have plus minus 3 d lambda over 2a plus minus 5 d lambda over 2a. So you can deduce directly that plus minus 7 d lambda over a. Okay.